Okay, now question number 9. So this one is, instead of it being in the horizontal plane, sekarang ni dia inclined sikit. Okay, so it is a 30-degree inclined plane connected to a freely hanging 1 kilogram block by a massless cable. Time tu lah kita dapat consider this. When the objects are released from rest, object A slides down the inclined plane with a friction force of 6 Newton. Okay, so we have to calculate the acceleration of the block and the tension in the cable. Okay, but before we start, please always remember to draw a free body diagram. Okay, so this one kita akan buat untuk this one dulu, block A. Okay, I usually prefer doing it this way supaya tidak confuse, tidak salah-salah. Okay, so for this we have the weight is there, and then we have kalau kamu bingung kan 30 degree tu di mana, kamu just letak dia melekat dengan the y component, always on the y component. Okay, and then the other friction force going against the motion. Then we have this tension here away from the object along the rope. Dia di sini lah kalau kita buat. Okay, so dapatlah. Betul lah. Okay, I'm just gonna remove this so that I can put it somewhere here. Okay, so don't forget to draw a dot to represent the object. Okay, so this is equal to 30 degree. This is mg. Patutlah namuat lampu. I used the wrong size. So this is 30 degree. This is mg. Oh, I forgot to label this. MA. Because kamu ada 2 M kan. Jadi mana boleh letak M je. You have to label what is the M. This is MAG. This is the friction force against the motion. So I'm just gonna label that as K. Because it's just moving kan. And then this is N. This is the tension. This is one string, so the tension should be the same. Okay, and then for the 1 kilogram block, it is just macam yang the previous one lah. So just pointing up and down. Okay, so it's just that one. Melampau juga. Okay, so that is MBG. This is T. Okay, this is T. Alright, now we have to okay, let me just extract what information that we have because it's easier that way. So this is 4 kilogram. MB is equal to 1 kilogram. And then what else? Object is released from rest, and we have a kinetic friction force which is 6 Newton. Okay, so we have to calculate the acceleration of the block. Okay, so acceleration of the block. Okay, now we are gonna use x and y component lah, sebab sekarang ni kita ada both x and y component. This is y component je lah. Okay, so we have to use both of this equation here lah. We have to create an equation from this block and this block. Lupa pula ni. Okay, so first let's do for block A lah. Okay, so for block A, we are gonna use component X. Kenapa kita guna component X? Sebab sekarang ni there are motion in the X component saja, which is pointing to the left. Okay, so this is our acceleration. Kenapa pula acceleration pergi situ? Sebab kamu nampak kan sekarang ni, velocity dia kan pergi sini. Dah kan acceleration dia pergi sini kan? Tidak logic lah. Okay, so that's why the acceleration is here, because the velocity is also pointing this side. Okay, alright. Now at this point pula, this acceleration will be pointing down lah. Okay, so acceleration tu akan berada di sini, akan tunjuk di situ. Okay, janganlah kamu pilih letak di atas sedangkan velocity tu turun ke bawah, bukannya akan naik ke atas. Okay, alright, let me just label this here so that you know which one is positive. So this is acceleration. Okay, so we only use the component that have acceleration. Jangan kamu pergi cari komponen yang tiada acceleration. Tiada guna lah sebab sekarang ni kita minta acceleration. Soalan minta acceleration. So for this block A, the only thing that has acceleration is the x component, which is ma a. Okay, so t will be positive because it is following the direction of acceleration. This is minus. Fk, don't forget mag because student always forget to do this one. Okay, so this is positive as well because it is following the direction of acceleration. Okay, so from here F is given, right? Yes, so T is the one that we will substitute later. Okay, so now for block B, we are only using the y component sebab the y component saja yang ada motion. Okay, so this is mbg minus t equal to mba. Okay, so we are gonna find t here. Bukan find t, we are gonna substitute t into this equation here. Okay, so t is equal to mbg minus mba. Equation 1. Equation 2. Salah ba ni? Equation 1. This one is equation 2. Okay, so substitute 2 into 1. So now it is mbg minus mba plus minus fk plus mag sine 30 degree equal to maa. Okay, so kalau kamu solve that, you should get the acceleration to be equal to 4.69 meter per second square. Make sure jangan terus letak begini ya, kamu substitute to mb itu berapa, fk itu berapa, ini semua ni berapa supaya dapat markah untuk solution. And then this one kamu punya final answer lah. Itu je kah? Belum lagi pula. Okay, now we have to calculate the tension and the table pula. So the tension of the table, we can just substitute acceleration into equation 2 lah. Jangan kamu substitute pergi equation 1, panjang betul. So substitute pergi here. So that you will get 5.12 Newton as the answer lah. Okay, alright, so that is question number 9.